Howdy! In this mini lecture we will discuss environmental health and hazards in toxicology. The student learning objectives of this mini lecture are: explain the goals of environmental health and identify major environmental hazards, define toxicology, toxicity, and environmental toxicology, describe the significance of Paracelsus, distinguish between a toxicant and a toxin, identify where toxins, toxicants are often stored in the body, identify factors that influence responses to toxins, and distinguish between acute and chronic exposures. Environmental health is the science that assesses environmental factors that influence human health and quality of life. Both natural and human-caused factors influence human health, as can be seen here. There are 4 types of environmental hazards that influence environmental health. The first is physical hazards, which are hazards that occur naturally in our environment. Examples include UV radiation, earthquakes, volcanoes, fires, floods, landslides, hurricanes, and droughts. Emergency planning helps us to prepare for some of these hazards, while preventive actions such as avoiding deforesting slopes, which prevents landslides, avoiding channelizing rivers, which prevents flooding, and applying sunscreen. The second are chemical hazards, which are caused by synthetic chemicals such as pharmaceuticals, disinfectants, pesticides, harmful natural chemicals, hydrocarbons, asbestos, and lead. We can reduce our risk to these through avoidance by choosing green cleaners or pesticides and by staying informed about chemicals you're exposed to. The third are biological hazards, which are hazards resulting from ecological interactions, for example, exposure to insects. Biological hazards include infectious disease, which is when viruses, bacteria, and other pathogens parasitize humans and cause disease such as malaria, cholera, and West Nile virus. The fourth are cultural hazards, which are the result from where we live, our socioeconomic status, occupation, or behavioral choices. Smoking is an example of a cultural hazard. Disease is a major focus of environmental health. Despite our technology, disease kills most of us. Over half of our world's deaths are from non-infectious diseases or conditions such as cancer and heart disease. Factors that influence incidence of these diseases include genetics, lifestyle, environmental exposure, poverty, and poor hygiene. Infectious disease kills 14 million people per year. Developed nations have far fewer infectious disease deaths than developing nations. Specifically, infectious diseases account for 50% of deaths in poor nations. Nutrition, sanitation, hygiene, and access to medicine all play a role in the spread of and deaths caused by infectious diseases. Social and environmental factors influence the spread of infectious diseases. Our global society makes it easier for diseases to spread across the world. This is further complicated by the fact that some diseases, like influenza, are caused by viruses that evolve rapidly and gives rise to new strains. With a global population, the spread of some diseases can be very dangerous, because they could result in a global outbreak of disease, such as what happened with SARS in 2003, H5N1 bird flu in 2004, and H1N1 swine flu in 2009 and 2010. Public health has decreased some infectious diseases. However, others, such as AIDS, are spreading globally. Public health is the science that promotes and protects the health of people in the communities where they live, work, learn, and play, by promoting healthy lifestyles and preventing diseases and injuries. Further complicating public health is the fact that some diseases, such as malaria and tuberculosis, have developed resistance to antibiotics. Another environmental factor influencing the spread of disease is global climate change. As climates warm, this enables tropical diseases, for example malaria, dengue, and cholera, to spread to temperate regions. While public health is the science of preventing disease and injury in individuals and human populations, toxicology is the study of the effects of poisonous substances on humans and other organisms. Paracelsus, who lived from 1439 to 1541, is considered to be the father of toxicology. He said, "All substances are poisons. There is none that is not a poison. The right dose differentiates between a poison and a remedy. Or in short, the dose makes the poison." This gets to the idea of toxicity, which is the degree of harm a chemical can inflict. Toxicity depends on the combined effect of the chemical and its quantity. Environmental toxicology deals with toxic substances that come from or are discharged into the environment. Environmental toxicology studies use animals and plants as models to see if chemicals may be a threat to human health. I was trained to know the difference between a toxicant and a toxin, and as such, it's important for my students to receive the same training. A toxicant is a synthetic or man-made poison. Examples include pesticides, herbicides, and solvents. A toxin is a poison from biological or other natural sources. Examples include snake venom, mercury, and arsenic. On this slide, you will see a list of a variety of environmental hazards to which you could be exposed. You should be aware of these hazards and educate yourself as a citizen and a consumer so that you can limit your exposure to high concentrations of these chemicals. You should be aware that toxic chemicals are all around us. They also exist naturally and in our food in some cases. Don't assume all natural chemicals are all healthy and synthetic ones are all harmful. This is not always true. Plants, even crops, can sometimes contain harmful chemicals. For example, some plants produce toxic chemicals to ward off being eaten. Meat can contain toxins that animals ingested from the plants and animals they ate. Both natural and synthetic chemicals are in our environment. Chemicals can be found in the air, soil, and water. What may be alarming to you is that every one of us carries traces of hundreds of industrial chemicals in our bodies. Furthermore, babies are born with chemicals already in their bodies, a quality known as pre-polluted. Children are especially susceptible to the risks associated with exposure to harmful chemicals because their consumption to body size ratio is far higher than adults. This is why chemicals are said to have a higher body burden on infants and children. Essentially, the same dose of a chemical will have a greater effect and impact on a child than an adult. This is why, if only one person or group of people in your house eats organic, pesticide-free food, it should be the children. Not all synthetic chemicals pose health risks. However, few of the hundreds of thousands of chemicals on the market have been tested. We will discuss this further in a different mini lecture on risk in toxicology. Organisms have been exposed to natural toxins for millions of years and have subsequently evolved natural defenses to some chemicals. For example, mercury and arsenic are found naturally in the environment, and some organisms produce toxins to avoid capture. Such toxins include snake venom, toxins in sea urchins, and pyrethrin in chrysanthemums. Skin, scales, and feathers act as barriers that prevent toxin intake, but toxins can enter into organisms through food, water, and air. Many organisms have biochemical pathways that can detoxify, or in other words, metabolize, toxins. When they do this, they make the toxins water-soluble so they can be excreted. The liver is a site of detoxification, so it is disproportionately affected by intake of harmful substances. Unfortunately, some toxins can't be detoxified in the body. Those that cannot be detoxified are sometimes stored in fatty tissues and cell membranes of the bodies of organisms, including us. Examples of compounds stored in the fatty tissues include heavy metals, dioxins, and some insecticides such as DDT. Even if an organism does not have a detoxification system for a particular toxin, defenses can be overwhelmed if levels get too high. Other toxicants are harmful at any level. Organisms have no natural defense against synthetics, and effects can be severe and unpredictable, which is why we must be careful when we develop new chemicals. Individual responses to hazards vary. Different individuals respond differently to hazards. Genetics can affect responses. People in poor health are most sensitive. Sensitivity also varies with sex, age, and weight. Fetuses, infants, and young children are also more sensitive. The Environmental Protection Agency, EPA, sets human exposure standards for adults and extrapolate down for fetuses, children, and infants. However, standards may not be low enough to protect the young. The type of exposure affects the response of an organism. Acute exposures are high-dose exposure to a hazard for short periods of time. Acute reactions usually occur quickly following exposure, are easy to recognize, and follow discrete events, such as ingestion of something, an oil spill, or a nuclear accident. Toxicity tests reflect effects of acute toxicity. Chronic exposures, on the other hand, are low-dose exposures over a long period of time. The response to chronic exposures is delayed, and the effects from chronic exposures are harder to detect and diagnose. Chronic exposures usually affect organs gradually, such as causing lung cancer or liver damage. With chronic exposure, the cause and effect may not be clearly apparent. When we are exposed to a compound, we will first absorb it into our bodies. Then the compound is distributed throughout our body by our circulatory system. Then the compound is metabolized. Finally, what is not metabolized will be eliminated. This system is referred to as ADME: absorption, distribution, metabolism, and elimination. These four processes are key processes toxicologists study, as these processes can affect how we respond to exposure to compounds. We can be exposed to a compound through inhalation, ingestion, or absorption. Of the three methods, ingestion and inhalation are the most common routes of exposure. That concludes the mini lecture on environmental health and hazards. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline. Thanks and gig 'em!